Right, hi. I want to talk about this marvelous thing called the normal force and how the normal force knows to push back with the right amount of force. And by that I mean if I'm on the ground and I have a cat, meow, and that cat is meant to be on the ground, it has, let's just say, a downwards force of 20 newtons. How does the ground know to provide an upwards force of 20 newtons so the cat doesn't fall through the ground? And yet when I stand there and I'm much bigger and I am much heavier and I have a much bigger force of say 800 newtons, how does the ground know to push back with 800 newtons? To balance my gravity and make sure I don't accelerate through the ground. The same ground, how does it know to do 20 newtons for the cat and 800 newtons for me? That's what we're going to talk about. So there's three little things I'm going to look at. First is I've got a spring here, and this spring I can pull down, and the spring gets compressed, or from the top I can push it. So looking at from the top, this is the first thing I want you to think of. If I put some mass on that, the spring pushes back. If I put a little bit of weight on it, a little bit of force on it, the spring pushes back a little bit. See, and when I pull it away, you can hear it pushes back a little bit. If I put a lot of force on it, push hard, the spring, get my hand out of the way, the spring is compressed a lot more and it pushes back a lot more. Take your hand out of the way, you can hear it. So push it a little bit, doesn't push back as much. Push it a lot, it gets compressed a lot and it pushes back much more. Okay, so that's the first one. The spring, here it is here. If I put something light on it, here's my spring. If I put something light on it, it compresses a little bit. If I put something heavy on it, it compresses a lot and it pushes back a lot because it's been squashed so much. The same thing, you can think of the same thing for with the spring as foam. So this is like the foam that I'm sitting on my seat now. My seat's providing a normal force on my bum. It's got foam on it. When I sit on it, I can squash the foam. If I'm very light, I squash the foam a little bit. And just like the spring, if I squash it a little bit, it's not as compressed, it doesn't push back as much. If I'm very heavy, I squash it a lot. When I squash it a lot, it's compressed a lot and it pushes back a lot more. So foam is very much like a spring. So when I'm sitting on my seat and I've got some foam on my seat, this is meant to be me. But if I'm very heavy, let's have a really big head to show up a heavy person. What happens is the foam is compressed a lot. Same as the spring. Spring compressed more when more mass added, and that means it pushes back more. It pushes back more, so more force when more mass added. And foam works the same way. So what about, we started off with the cat on the ground. Well, it turns out that the ground, if you looked at it under a microscope, here's my picture of a ground, it's actually made up of lots of atoms. And those atoms aren't completely beside each other. There's little tiny gaps behind them, between them. When the cat sits on the ground, you can't see it much with the naked eye, but if you were to look at it microscopically, what you'd find is, here's my ground. When the cat sits on the ground is compressed a little bit. There's my cat sitting on the ground. And these atoms are just a little bit closer together than they were before. And the ground was this far apart. Now it's just a little bit closer. So it got squashed like the spring got squashed. And then when something really heavy comes along, the ground gets squashed even more. So now these atoms are even closer together. And they're just like a spring. The closer they get, the more they get pushed together, the more they push back. So we've taken an idea of a spring, and we've said how foam is like a spring, and we've actually said how the atoms in the ground are like a spring. Are like a spring. That is the reason why the normal force knows how to push back as much as it needs to. It's because the ground or the seat, or whatever you're sitting on or standing on, gets pressed together. The heavier the object is, the more it gets pressed together. The more it's pressed together, the more it pushes back. And so it's how it knows. So maybe that's worth taking some notes on in your lab book about the normal force.